Okay, guys, section 12.3, multiplying monomials and polynomials. And guys, you're going to see here that, looking at this first one, outside the parentheses, I have 3x, and 3x is a monomial. Okay. Inside the parentheses, though, right here, I've got two terms, 5x and 6. Remember, terms are separated by pluses and minuses. Okay. So I've got two terms inside the parentheses. So that polynomial is actually a binomial, because bi meaning two. Okay. Now, guys, we don't do this thing any differently than we've worked all along. We're going to need to distribute. Okay. The 3x needs to get multiplied by both of the terms, not just one of them. All right. Now, just before we move on, you guys need a little bit of vocabulary here. And that is, let's look at 3x. The number in front of the variable, this is one term, right, 3x. The number in front of the variable, this thing is called a coefficient. Now, I need you to learn it, because if you don't, I'm going to probably start yelling at you. That's why I'm telling you now. Okay? The number in front of a variable is called the coefficient. So if I look at the first term inside this binomial here, what's the coefficient of that term, Max? Good. Now, I think you've got that idea down now, what a coefficient is. All right? Now, what we need to do is we need to distribute the 3x. We need to multiply. Now, I'm not going to always write it this way, because it just gets cumbersome and it gets in the way. All right? But let's, for this one time, so you'll see what's happening, I multiply 3x times the first term, so I get 3x times 5x. And then I'm going to multiply 3x times the 6 here, plus 3x times 6. All right, so now I've written out exactly what it is that we're doing. Okay? Now, Edward, when I multiply these two terms, right, they're not really terms because it's all one multiplication problem. When I multiply 3x times 5x, I multiply the numbers. What do I get? 15. And I multiply the variables. Edward, what do I get? Not just x, but x squared. X times x is x squared. Remember, exponents are repeated multiplication. So x times x means x squared. All right? Now, I'm going to multiply positive 3 times the 6. What do I get, Kyle? Positive 3 times 6. Excellent. Positive 18. And I only have 1x, so I just keep that 1x. Now, Benny, can I add these two terms together? No, I cannot, because they're not like terms. They both have x's, but one's x squared and one's just x. So I want you to think about this for a second, just a little side problem over here, and I'll erase it in a second. But think about this. If I have 3 7s plus 8 times 7, do you see that that's 11 7s? Right? I've got 3 7s and I've got 8 7s. But wait a minute. What if that's 3 7 squareds? Can I put those together now? No, because 7 squared is a different number. 7 squared is 49. I've got 3 49s and 8 7s. I can't add those together. As soon as that exponent is different, they're not like terms anymore. I have to have the exact same variable stuff behind the, what's the term? Raise your hand. What's the term, Troy? Coefficient. The exact same variable stuff behind the coefficients to put them together. All right? Good. Now I'm running out of time here, but I think that's okay. Let me get rid of this, because I think we'll be all right. Guys, for this one, the binomial is in front. That doesn't matter. We still do it the exact same way. I'm going to distribute the negative 5t squared into the binomial. So, Charlie C., the first thing I get is negative 5t squared times positive t. What does that give me? What's in front of the t? No, what's in front of the t? 1. So I multiply the coefficients. What do I get? Negative 5. Negative 5 times 1 is negative 5. And then I multiply variables. T cubed. I add their exponents, right? Good. That's the first term. But I still need to distribute at will to the second term. What do I get when I multiply negative 5 times negative 4? I get positive 20. Great job, because a negative